All right, we're going to graph sine and cosine functions. So here we go. By the way, don't do these notes until you've taken the notes in class. So if for you day 2 people, if you're watching this video, wait until after I see you on April 11th to take these notes. I mean, if you want to, I guess you can now, but otherwise just wait. So, okay, the first thing I had you do after you copied notes out of the book in class was write down this problem. So we're going to graph h of x equals 1/3 cosine 2x. What we had to do is we had to find the amplitude and the period. I'm going to abbreviate amplitude for amp. All you do to find the amplitude is take the absolute value of a, which is the number in front of the sine or cosine. That means taking the absolute value of 1/3, which is just going to be 1/3. So your amplitude is 1/3. What that means is, on the y-axis, your graph of cosine, which is an oscillating graph, will never go beyond 1/3 this way on the y-axis, and it'll never go beyond negative 1/3 down here. So if we label this 1 and negative 1, we may actually want to divide this into thirds because of our amplitude. So maybe this is 2/3 and this is 1/3, and maybe this is negative 1/3 and this is negative 2/3. So yeah, our graph as it oscillates, or it has that period, it'll never go beyond 1/3 and negative 1/3. Now we also need to find our period. Our period is 2 pi divided by b. B is the number that's before x. In this case, it's 2. Sorry, this is the absolute value of b. So we have 2 pi over absolute value of 2. Absolute value of 2 is just 2. And we have 2 pi over 2. What happens with these 2's right here is they cancel, leaving you with the pi. So what that means is your function, this function right here, repeats over every interval of pi. Every interval that's pi long. So we're going to be drawing 2 periods in this graph. So we're going to go 1 period going this way. So from 0 to pi, that's 1 period. And then another period of the repetition of the function would be negative pi. Now between 0 and negative pi, what's halfway between 0 and negative pi? Well, that would be negative pi divided by 2. And then over here, I have pi divided by 2. Okay? So let's go ahead and draw the graph now. Let me find another color to use here. I think red might be a nice little color. All right. So the thing to remember with cosine graphs, I was going to remind you from the notes, is that they start high. There's 5 special points for every period. They start high, they hit the x-axis, they come down to the lowest point, they come back up, and then they come back up again, and they form a curve that looks like this. We're just gonna apply that same shape here, but you gotta remember our highest point is not 1 from the original graph. It's now, so our amplitude is 1/3. So instead of starting all the way up at 1, oh sorry, I said it was gonna draw in red. My bad. Red. There we go. So now we're gonna hit 1/3. We're gonna hit the x-axis right here. Now we're gonna go to this point because we're halfway there. Halfway there is gonna bring us at a minimum of negative 1/3. We're gonna come back up right here and hit the graph, and then come back up here. So that's 1 period. Oops, sorry, ignore that. Now we're going to repeat that process over here. Now this point represents something like this point. So we're going to keep, remember it's an oscillating pattern. We're going to keep going in this oscillating pattern here. And so we have a graph that looks like something like this. Now you got to remember the graph oscillates like this forever in both directions. Why do I say that? Because that talks about your domain. Remember, your domain is what x values are allowed in this function. Well, if this graph goes forever in both directions, your domain is all real numbers. Now your range is going to be what is allowed in your y-axis, but we said that the graph can go no further than negative 1/3 and 1/3 in this direction, and so that's going to determine our range. Our range is going to be negative 1/3 is less than or equal to y is less than or equal to 1/3. So that keeps our range between those two values. So remember, this is the shape of your cosine graph. Okay, this is the shape of cosine of x. By the way, on the x-axis, this is the point pi. This is the point 2 pi. And I only drew one period of it. Remember, we drew two periods right here. Okay? Actually, let me just talk about that a little bit more. Like, if I was to just draw cosine x, this is this graph right here. Actually, I'm not going to do that. No, sorry. We'll not do that. All right, let's go ahead and do this one. We have f of x equals 2 sine x. So we want to find the amplitude and the period. Amplitude is just taking the absolute value of the number in front of the sine or cosine. In this case, we just get 2. So that means that on the y-axis, we're actually going to have to make 2 marks because our amplitude is going to be going pretty high at 2. And the lowest, it'll go as -2. So we have 1, 2, -1, -2. Okay? Let's go ahead and find the period now. The period is going to be 2 pi over the absolute value of b. Now, b in this case is just a 1. This is 1x. So I have 2 pi over the absolute value of positive 1. But absolute value of positive 1 is still positive 1. And 2 pi over 1 is just 2 pi. So that's how long my one period is. From 0 to, we're going to say from 0, leave room for 1 mark, but then 2 pi right here. And then, because we're going to be drawing 2 periods here, we're going to go to -2 pi right here. Now, we should probably label these as well. If this is -2 pi, it looks like this would have to be negative pi. Can you predict what will go here? If you predicted pi, you are correct. Okay, now to remind you of what the graph of sine looks like, it looks similar to cosine, but its starting point is different. It starts at 0, 0. Here's the highest point and the lowest point it'll go. So it starts at 0, 0. Then it goes up. Sorry, it's up. Actually, I messed it up. Wow, sorry. It's been a weird day. I apologize. All right, sorry. Here's the highest point, lowest point. Here's the 2 points that are like these. It starts here, goes up, comes back down, goes all the way down, and comes back up. So our sine graph looks like this. Okay, so this is sine x. All right, so this is the shape we want to take on for every period of the function. All right, so let's go ahead and do this. In fact, yeah, we said we're going to choose red for graphing. So just like this graph starts at 0, 0, so does this. It's just the difference here is instead of going up a unit of 1, the amplitude says to go all the way up at 2. So all the way up here. Then you're going to come back down to pi. Then you're going to go all the way down. And then all the way up. Now we want to repeat that for this period. So, if you want, you can start from here and repeat the process. So you have starting here. Then you're supposed to go up. Come back down. Go down all the way. Come back up, but you already have that point there. And then just draw a nice, very curvy... Looks like a bunch of parabolas stringed together, actually, doesn't it? Okay. That's your sine curve. And we want to get the domain and range. So domain is just like cosine. Sine goes forever in both directions. So domain is all real numbers. The range, remember, it's what it oscillates between. That's actually the word for it. It's called oscillating. When your function like this repeats over time, forever in both directions, it's oscillating in both directions. This function oscillates between -2 and 2. And so that's what our range is going to be. Let's try one more, and then I have a couple that I want you to try. We're going to graph sine 2x. Okay, so we want to find the amplitude first. The amplitude is the absolute value of A. That's how I remember it, by the way, amplitude A. And A is the number that's in front. Now, if you look here, there's nothing written, but you assume there's a 1 there. So it's the absolute value of 1, which is just 1. So for our y-axis, it's just like a normal sine curve, like if it was just sine of x. So we're going to be going between 1 and -1. And you know what? If you see it right away that we're going to be going between those, you can just say your range right away. And actually, your domain is going to be all real numbers. So we actually can take care of that right away. It's pretty easy. Let's go ahead and get the period. We have 2 pi over b. Sorry, absolute value b. B is number that's before x. Now b in this case is 2. Absolute value 2. Okay, we can kind of skip the step. You know the absolute value 2 is 2. 2 over 2 is going to reduce, leaving you with what? With pi. So you're going to go from 0 to pi, but make that other mark. And then we need to, so that's one period. And then we need to go, 0 to negative pi. And then what would this be? Do you recall what this would be? Let's see if you can recall that real quick without looking at your notes. All right. So this would be negative pi over 2. And then this would be pi over 2. Okay. So just recall sine of x starts at 0, 0. It goes up, comes back down, goes all the way down, comes back up. It's a graph like that. So this one is going to start here, go all the way up, come back down, go all the way down, come back up. And we want to repeat that process for this period. Go all the way up, come back down, and just draw a nice sine curve. All right? So again, this is one period of the function. This is another period that repeats the same exact pattern. There's an infinite amount of periods in both directions. All right. So why don't you try these yourself? And I will have the answers to these as a link, probably an Imager link in the description of the video. And here's a really clever thing I found online. I want to see if anyone can figure this out. 1 over n, and this is a times if you want. This is 1 over n times sine of x equals 6. But how? Can you figure out how that happens? Find out next time. Okay.